Thank you for going through my previous lectures. And this is my fourth lecture on the lecture series Straight Line in Space. Okay. So today in this lecture, I am going to discuss these 4 points. The first one point is this, like on finding the angle between the two lines, basically in the form of Cartesian equation. Cartesian equation. Okay. Then second is on finding the equation of line parallel to the given line. First one is given that parallel to the line and passing through one point. Okay. Similarly, the second one is given as like on finding the equation of line passing through a given point in perpendicular to a lines. Same. Okay. So all these will be discussed. All these topic will be discussed in this lecture. So just start with the first point. Okay. First point is on finding the angle between two lines. So as we discussed in previous lecture that we are going to find out the angle by this formula a dot b upon mod of a and mod of b, where a and b are vectors. Okay, vectors. So how we find the angle between two lines? Basically, lines are given by in vector form. In vector form, lines are given by in vector form lines are lines are given by given by r1 equals to a1 plus lambda b1, where a1 is a position vector and b1 is the vector. Okay, then r2 is given by a1 a2 plus lambda b2. So how we find the angle between these two lines if they are given in the vector form? So in vector form, we are going to discuss like cos theta equals to b1 dot b1 dot b2 upon mod of b1 in b2. This will give the angle between the two lines if these are the in vector equation, which is discussed in the previous lecture. Okay, lecture number 3. In this point of the things, we are going to discuss about the Cartesian equation. What, why, how we define, how we are going to find the angle when the Cartesian equation is given. So on the behalf of that, we are just taking the example just how we are going to discuss to find the angle when the Cartesian equation of line is given. So first we have to convert these that Cartesian equation into the vector form and then extract the b1 and b2. Okay, so the conversion of Cartesian equation to the vector equation is explained in the lecture number 1. So if you are not well on that topic, you just go through the first topic and then come to this topic. Okay, but partially I can explain here. So just I'm taking the example that how we find the angle when the Cartesian equation is given. So question number 1 is this, that the question number is given like one thing. Yep. So we are going to take an example like L1 is given by find the angle between the between the line. The first one is like x minus 2 upon 3 equals to y plus 1 upon minus 2 and z minus 2 equals to 0. And the second line is x minus 1 upon 1 equals to 2y plus 3 upon 2, 3 plus z plus 5 upon 2. So in this first we are going to make this equation as a standard Cartesian equation. So how we make this equation as a standard Cartesian equation? Just same as we are going to do that. First we have to take care of the coefficient of x and y and z. For example, this. So we have to make this as just took care like x minus 1 is equals to y plus 3 by 2 upon 3 by 2. Okay, equals to z plus 5 upon 2. Then we are going to extract the ratios of that. Okay, line. This is okay. Then what is the a1? A1 is 3, b1 is minus 2, and c1 is 0. And what is a2? A2 is 1, b2 is 3 by 2, and c2 is 2. So we are going to put the equation cos theta equals to a1 a2 plus b1 b2 plus c1 c2 upon under root a1 square plus b1 square plus c1 square under root a2 square plus b2 square plus c2 square. Okay, so a b and c are the direction ratios. Here a1 b1 and c1, a2 b2 and c2 are the direction ratios of the lines. So we can also find the angle by using the direction ratios. Okay, so just put the values of a1 a2. So 3 a1 a2 into 1 minus 2 into 3 by 2 plus 0 upon under root 9 plus 4, then 1 plus 9 upon 4 plus 4. Okay, this will give out the things like 3 minus 3 upon, this will cut out upon under root 13 and under root 1 plus 9 upon 4 plus 4. This will give out the 0. Okay, so what is the value of cos theta? So cos theta is equals to 0, then theta equals to cos inverse 0. So theta equals to cos inverse cos 90 pi by 2. So theta is equals to pi by 2. So by using this phenomenon we can uh, find the angle between the two lines. Okay, when the equation is given in the Cartesian form. Okay, now we'll move to the second topic is that on finding the equation of line parallel to a given line and passing through a point. So what is the second topic? Just finding the passing equation of line passing through a point, through a given point, given point and parallel to a line, parallel to a line. So what is going on? For example, just like that, if a line is given and the second line which is our required line is this. So the slope, we can say that the direction cosines or direction of this line is same equals to this, proportional to this line. Okay, so by using the direction ratios we are going to find the things like that. We are going to take a question on that, and then after that we'll explain step by step. Question number 2. So how we explain that things, just okay. So just question is, find the equation of line. Find the equation of line passing through a point 2, -1 and 3, and parallel to the line, parallel to the line I plus j plus lambda 2I plus j minus 2. Okay, so just we are going to this. So what is the equation of line? The equation of line is given by, in vector form, r equals to a1 plus lambda b1. Okay, where a is the position vector, where a is given by this. So what is a1 in this question? 2I minus j plus 3k. Okay, a1 is the position vector, and b1 is the vector of which the direction ratios are proportional. So if the required line is parallel to the given line, this is the given line, and this is the required line. Okay, so the direction ratios of both the lines are same. So what is the b1? B1 is extracted from the itself, from the given line, 2I plus j minus 2k. Then the equation of line is, the required equation of line is given by 2I, putting the value of a and b in this, 2I minus j plus 3k, okay, plus mu 2I j and minus 2k. Okay, so this is the equation of line in the Cartesian form, in the vector form, in vector form. Okay, in vector form. If the if the answer is asked in the terms of Cartesian, then please go through the lecture first, how we convert the vector form into the Cartesian form. There was a good explanation on that topic. Okay, then after three after this topic we are going to our third topic. Third topic is given by perpendicular on, find the equation of line equation of line passing through a given point, passing through a given point, through a given point, and perpendicular to two given lines. So what we are going to do in this? So given two given lines. So first thing, the two given lines are in the vector form, just like that r1 equals to, sorry, just like r1 equals to, we are going to change the color, just r1 is given by a1 plus lambda b1, this is given, and r2 is given a2 plus lambda b2. Okay, so the perpendicular on these lines. So what is the direction ratios of the required line? For example, if the line is given by, first line is given by this, second line is given by just like suppose that this, okay, then what is the direction ratios of this line? So direction ratios is this, okay. So we are going to find the cross product in this L1 and L2, okay. So how we are going to find the a for required line, a for required line, a where a is the position vector of required line, okay. Okay, this is given by two given point, by a given point. So we can find the position vector from the given point and the direction ratios from the two given lines, okay. So and putting that value in this, so what is the required answer of that? A a given plus lambda b1 cross b2, okay. This will be the required equation of the lines, okay. So let's take an example and then do the questions on that. Okay, question. So how we are going to discuss that? Just like, yeah, the vector equation. So the find the find the Cartesian equation. What is the Cartesian equation? Find the Cartesian equation. In this question, they are asking about the Cartesian equation. Okay, so th- find the Cartesian equation of the line passing through through point is given by through -1, 3 and -2 and perpendicular to the lines, and lines are given by x upon 1 equals to y upon 2 equals to z upon 3, and x plus 2 upon -3 equals to y minus 1 upon 2 equals to z plus 1 upon 5. So uh, first we have to check that the given equation is in a standard form or not. So in this equation, both the equation of lines are in a standard form. So first we have to convert, we find the values of a, b and c. So how we find the values of a, b and c? So just we go through the first convert these equation into the vector form, and then we are going to find the things. So how we do that? So put lambda equals to, okay, in both equation, to lambda, then find out the value of x and y and z. So x equals to lambda, y equals to 2 lambda, and z equals to 3 lambda, okay. Now in this, x equals to -3 lambda minus 2, y equals to 2 lambda plus 1, and z equals to 5 lambda minus 1, okay. Putting these values on that, so r equals to 0 vector plus lambda 1 I plus 2j plus 3k, okay. And from this, r equals to, separating out the constant things, okay, just 3 lambda minus 2i plus 2 lambda plus 1 j plus 5 lambda minus 1 into k, separating out the constant things and the values with the lambda. So r is given by this, so minus 2i plus j minus k plus lambda is common, then 3i minus 3i plus 2j plus 5k. Okay, now we just find out, we just find the things like this is our b1 and this is our b2. So what is the b1 and b2? So how we find the a b1 cross b2? This is b. So b1 cross b2 is given by b equals to given by I, j and k. So what is the b1 coefficient of I is 1, 2, 3 and minus 3, 2 and 5. So this will give the b vector of the required equation. So I 5 2s are 10 minus 6. So 10 minus 6 minus j, this will cut out, and then 5 plus 9. Okay, then 5 plus 9 and plus k equals to 2 plus 6. Okay, so what is the that 4i minus 14j plus 8k. This is the crossed equation. Okay, and after that we just do the things like that. Okay, so b is this. If we just so required equation is equation of line is r equals to a, where a is the position vector. Position vector is the point from the line is passed. So position vector is minus I, okay, plus 3j minus 2k. So minus I plus 3 3j minus 2k, 3j minus 2k, okay, plus lambda 4i minus 14j plus 8k, where lambda we are going to take common from these values. So what is r equals to minus I plus 3j minus 2k, okay, then plus 2 lambda, we can say that 2i minus 7j plus 4k. So the required answer in the vector form is r equals to minus I plus 3j minus 2k plus mu 2 lambda equals to mu. Basically we mu lambda is all these things are constant. So 2i minus 7j plus 4k. If this is the required equation in the vector form, if we want in the Cartesian form, then we can do that things like x plus 1 upon 2 equals to mu. We are going to compare these things and then find out, okay, by mu and x x minus 3 upon minus 7 equals to mu, and x plus 2 upon 4 equals to mu. So the Cartesian equation is given by x by x plus 1 upon 2 equals to x minus 3 upon minus 7 and x plus 2 upon 4. This is the Cartesian equation. Okay, this. Okay, so a special lecture is given That is lecture number first in the straight line. How to convert the Cartesian to vector, vector to Cartesian, and all that things are given. Okay, in lecture number first and lecture number second. Now we'll move to the our fourth topic. Our fourth topic is just what is the just on perpendicularity of two lines. How we can find that the two lines are perpendicular? So basically, how we find that? We are just going to give the heading of our topic, just like fourth topic is on perpendicularity of line. Perpendicularity of line. If the angle between the two lines are 90 degree, then it's called, if theta equals to 90 degree, this will result in perpendicular lines. Okay, so how we can find that the two lines are get the two given lines are perpendicular or not perpendicular? So first we are going to take the things like that. Okay, so how we can do that? Basically we just do that with the help of ratios, direction ratios. So how we are going to implement that? Just take in question, and then by with the help of that I'm going to explain the things. Okay, so just one thing, if the two lines are perpendicular, so the values of a1 a1 a2 plus b1 b2 plus c1 c2 equals to 0. Okay, this will give out the things. Okay, so if the lines are given in the Cartesian form, for example, uh, just we are going to take an example like okay, just question number 1. Question is given by that question, so that so that so that the lines x minus 5 upon 7 equals to y plus 2 upon minus 5 equals to z upon 1, and x by 1, y by 2, and z by 3 are perpendicular. Okay, so in this we are first we have to check that the given equation in the Cartesian form are in standard or not. If they are in standard, then no issues about that. If they are not in standard, then convert that equation into the standard form and then do that. What is the standard form? Standard form is that the coefficient of x and y and z are unity. Okay, this will give out the standard form. Okay, so just this equation is given in a standard form. So the value of a1 is 7, a2 is minus 5, and sorry, not a2, b1. Okay, b1 b1 is minus 5, and c1 is 1, and the values of a2 is 1, b2 is 2, and bc2 is equals to 3. Then putting these values. Okay, so cos theta equals to a1 a2 b plus b1 b2 plus c1 c2 equals to 0. This will give out the perpendicularity concept. So the cos theta equals to, okay, if a1 a2 b1 b2 and c1 c2 are equals to 0, then the given lines are perpendicular. So just 7 into 1 minus 5 into 2 plus 1 into 3. Okay, the 7 then 10 plus 3. So this equals to this 0. So when this is 0, that means that cos theta, that means cos theta equals to 0. Then theta equals to cos inverse 0. This will give out the cos pi by 2. So by using this formula, we can use cos theta. We can also use the formula like cos theta equals to just like b1 b2 b1 dot b2 upon mod of b1 and mod of b2, where b1 b2 are the vectors, okay, are from these equations. First the vectors from this direction ratios, okay. So by using that we can also find that, okay. So this is enough for today. Thank you for giving me time to produce the lecture, and just suggest something. If you if the things are not clear, then please comment out in the section, and I'll absolutely help you, okay, with these topics. Okay, thank you, and once again, just like and subscribe the channel.